Before I do number 31, I want to just caution you. If you are not very well versed in algebra, you may want to just make a guess on this one and skip it. And if you look at my page, you can see that I'm actually coming back to this one because that was my plan. I thought, unless you've had some pretty in-depth study in algebra, this is really going to be complicated. But then I know that there are some teachers and some students who want to know how to do this. So I decided to come back and do it. But I would caution you that if you're easily confused with algebra, just skip this one, make a guess, and keep going. And it's fine. It will not hurt you in the long run, even if you guess wrong. But for those of you who do want to remember or know how to do it, I will work it for you. I had to review the basic formula for a cubic equation. It's been a very long time since I looked at this. So let me share that with you in case it has been a long time for you. So the basic formula, the generic form of a cubic equation, remember cubic means that there are 3 roots to this equation, would be a, which is your coefficient, x minus the first root times x minus the second root times x minus the third root. And as I'm putting in x minus, I am building in binomials. So that's one reason this problem is difficult, because we have to multiply a lot of binomials. But that's okay. We know how to do that using FOIL. It's just a little bit, it's not a little bit, it's quite in depth. Since they did not specify a coefficient value, I'm going to let a be 1. And I'm establishing that value myself because I want something easy to work with, and they didn't limit me with another coefficient. So I'm going to assume that a is 1. The other thing that I have to remember is the definition of a conjugate. And without going into it deeply, let me just say this. The conjugate of 2i, and let me read the question. It says, find the cubic equation that has -1, 2i as roots. Now, if it's a cubic, it has to have 3 roots, and they've only given me 2. So let's say that root 1 is -1. Root 2 is 2i, where I stands for imaginary. So I need to know a root 3. And this is where conjugate comes in. The conjugate of 2i is -2i. And that will act as my third root. And again, this goes into some deep algebra concept instruction that I'm not going to do. I'm assuming that you know these things. If not, skip this problem. Okay, now we are finally ready to set up our equation. And if you look at these choices, they are remarkably close. If you just look down through there, the first 2 terms of these equations are the same except for signs. The third term is the same except for signs. And then the fourth term is, the constant term is either a 4 or a 1, and the sign changes. So we have to be very careful here with signs. And that has always been one of my weaknesses. I'll get in a hurry and I'll lose track of my negative and positive signs. So I'm going to slow down and show you how I would work this problem. Rather than write all this again, here comes the cat, so hopefully nothing goes awry. She wants attention this morning, and we'll get it because she is very persistent. She's fascinated with the iPad too. All right, so I'm going to change colors now that that background stuff's out of the way, and let's start plugging in numbers here. So A, again, we're using a 1 as a coefficient. That is so that I do not have to multiply a value through. 1 does not change the value, and it's a positive 1, so it will not change the sign. Okay, for my root 1, I used the negative 1. For my root 2, I used 2i. And for my root 3, I'm using the conjugate of 2i, and that's negative 2i. And so let's go ahead and change some signs here. This will become positive, as will this. And as soon as I do that, I can see that I have a difference of squares right here. This is negative 2i, positive 2i. So this is a difference of squares. That's another background thing that you would need to know in algebra. So we have two binomials that are difference of squares. And so that makes life a little bit easier right here. Knowing that difference of squares rule, where a squared minus b squared is going to be your outcome, I can say that the outcome on this multiplication would be x squared plus 4. So when I would multiply that difference of squares, I would get x squared plus 4. And then we have this other binomial over here to be multiplied. Okay. So we are going to say that we FOIL this one because it's not a difference of squares. FOIL. So the first terms will be x and x squared. So that gives me an x cubed as the output. The outside terms are x and positive 4. And that would give me a 4x as the output. And then the inside terms, I have a 1 and an x squared. So that would give me x squared. And then the last terms are positive 1 and positive 4. So that would give me a 4 on my last term. So if you put these in standard form, you would get your final equation, which looks like this. We just need to match it to our answers at the top, our choices. And I am liking D as in Delta. Again, all of the stuff in blue, it is assumed that you know. So if you have not had in-depth algebra, I would definitely just skip this question and move on. Make a guess, don't leave it blank, but I would skip it and move on.